Here's our next lesson. This is going to cover distributive property as well. However, this lesson is going to take more of an algebra angle with how we approach the distributive property. The learning target is you, the student, will break down, model, and practice using the distributive property with variable and non-variable terms. In our first example here, I'm going to go ahead and talk you through this. You're going to want to write down the steps and the procedure for solving a problem like this. So the first step is to distribute by multiplying 8 into x and 5. So you multiply and you get 8x. And then you're going to multiply 8 times 5. Now when you do the multiplication, 8 times x is 8x. 8 times 5 is going to be 40. And you're finished with that problem. It doesn't look like it's finished. That's been kind of a recurring theme lately with our assignments. But that is it. That's all you can do with this problem. Hopefully the only thing that might confuse you a little bit is right there with the 8x. When you multiply a number times a letter, 4 times n, the answer to that is 4n. If you're multiplying 3 times g, that's going to be 3g. So you're just going to basically put the number and letter together. This is the coefficient, and this is your letter. In our next example, what we're going to do is we're going to look at an area model. And in this example, we have x's and we have constants. And what we're going to do is we're going to basically find the area of this rectangular region using the distributive property. What we need to do is we need to do length times width. And we don't know what the length is. We don't know what the length is right off the bat, but we do know that the green strips are x, and we know that the red squares are constants. So this is equal to x, and then the red part is 2. And so together, that makes an expression x plus 2. And then what we're going to do is we're going to set up our distributive property. So we're going to do length times width. 3 is our width. Width times length is all the same. And then we're going to put x plus 2 inside parentheses. And now it's just a matter of using distributive property. Drop down the plus sign. 3 times x, and then 3 times 2. Keep in mind that 3 is being distributed into everything. So don't just distribute 3 into x, distribute 3 into x and 3 into 2. Now 3 times x is 3x. 3 times 2 is 6. And that's your answer, 3x plus 6. So the area of this green and red region is equivalent to 3x plus 6. So if we know what x is, we just have to plug it in. If x is 5, then it's 3 times 5 plus 6. So that's that. Okay, in this model, what we have is we have to find the area of just the green region. Okay, we know that the length of this entire rectangular model is f. It's f inches, it's f feet, it's f units long. We don't know what it is, so we're going to use f. We do know, however, that this region is 3. So if we need to figure out this part, which we do, because in order to find area, we need to do length times width. So we need to know what this is, but we can't call that f. We know f is equal to the entire thing. So this region will be the difference of f and 3. So difference means what? It means subtract. So you're going to write f minus 3. So this region right here represents whatever f is minus 3. So for instance, if f is 10 units, if from here to here is 10 units, well then this region will be 10 minus 3, which is 7. So 7 plus 3 is 10. If this region right here is 16 units, if f is equal to 16, well the green length will be 16 minus 3, which is 13. And 13 plus 3 is 16. So now we have everything we need in order to use the distributive property. And now we're just going to set it up. 5 is outside. 5 is going to be distributed into the f minus 3. And then we just distribute 5 times f and then 5 times 3. Drop down the subtraction sign and is 5f. 5 times 3 is 15. Drop down the subtraction sign and you're through. There's nothing else you can do with this problem at all. Okay, and this next one, this is a pretty simple one. Find the area again. So I don't have it split up into special parts. All I have is a length and a width. We know that the length is h plus 6, and we know the width is 8. So we're just going to multiply using distributive property. So there we have it. So 8 times h, and then 8 times 6. Drop down the plus sign. 8 times h is what? It's 8h. Nothing very complicated about that. 8h. 8 times 6 is 48. And that is it for that problem. That's all you can do. We're through. We are finished. 8h plus 48 is your answer. If we know what h is, then we have all the information we need to figure it out. if we know h is 2, then we just do 8 times 2, which is 16. 16 plus 48 is 64. All right, in one of our first examples here, we have 11 times the sum of m plus 9. And in this example, we're going to distribute the number 11. So we're going to multiply 11 times m, and we're going to add that to 11 times 9. And now it's just a matter of kind of putting everything together. 11 times m is basically just 11m. 11 times 9 is 99. And that's how you use distributive property. That's pretty much it. That's all we can do to this problem. So these are not like terms. This is a variable term. This is a constant. You cannot add variable terms with constant terms and vice versa. That's it. In the next example, I have 6 multiplied by the difference of w and the letter I. And in this example, we're going to distribute the number 6. So 6 times w minus 6 times I. Now what makes this example just a little bit different from the previous one is that everything in parentheses is a variable. There's no numbers in the parentheses. So we're straight up multiplying by letters, by variables. So 6 times w is going to be just 6w. 6 times I is going to be 6i. And that's all you can do with this problem. We are absolutely finished. Those are not like terms. You cannot subtract them. There's no way to put them together. They're not the same. In example number 3, we're going to multiply the number 1 by the sum of m and v. So we're going to distribute the number 1, and you're going to get 1 times m and 1 times v. When you multiply by m, when you multiply 1 by m, you get just m. When you multiply 1 times v, you get 1v, or just v. And that's all you can do. The answer is m plus v, which seems kind of weird, but that's what happens when you multiply by 1. It's always the same. When you multiply by 1, nothing really changes. 1 times 8 is still 8. 1 times negative 3 is still negative 3, even though you've never dealt with negative number multiplication yet. 1 times pi is still pi. Multiplying by 1, identity rule, just keeps everything the same. So that does it, everybody. Hope everyone understood this lesson. Please make sure you bring your notes to class the next day, and have a great night.